Okay, what we're going to have a look at here is basically this problem we have with the volumes of revolution problem in a P4 exam. Okay, so have a read through the question first. The curve shown in figure 2 has equation y equals 1 all over 2x plus 1. The finite region, okay, bound by the curve, the x-axis and the lines. So there's the curve, the x-axis and the lines, x equals a, x equals b, is shown in figure 2. This region is rotated through 360 degrees about the x-axis to generate a solid of revolution. Okay, the volume of the solid generated, find the volume of the solid generated, express your answer as a single simplified fraction. That's quite important to pick up, the full 5 marks on this. Okay, so what do we got here? We got effectively got, it's going to generate, it's much easier to write this. Going to generate something that looks a bit like a trumpet, isn't it? Okay, so an element of volume then, let's expand that out a bit. Oops. Okay, so we've got a delta x there. Delta x there. Why I can't have problems with that. That's going to be y there. Okay, so an element of volume then is going to be delta v is going to equal pi y squared to get the area and a delta x to get the volume. Okay, the next time that thing flashes at me, I'm going to kill it. First, look at the next steps on this next page. So what we want to do basically is integrate this up now. So we're going to put an integral sign here, put the y in there, integral delta v equals the integral from a to b, take the pi out, okay, of y squared delta x. Let's move down a little bit more. Whoops, not quite that far though. Okay, so what we're going to do next is basically substitute our y from here to give us x here, so we can integrate it up. Okay, so this then, let's put v here as well. V equals the integral delta v. Yeah. Okay, is equal to pi integral from a to b of 1 all over 2x plus 1 squared delta x. Now, okay, how are we going to do this? Move down a little bit. So when you look at this, okay, let's have a little bit of an aside here. Okay, I'll draw a little bit of a line. What you're looking for here, you know basically from what you should know from differentiating things, that what you're looking for is something like this. Okay, it's going to come out to be something like that. Now what do I get when I differentiate that? Okay, when I differentiate this with respect to x, what do I get? Well, I get a minus 1 from differentiating the bracket as a whole. Use the cover up rule. Okay, put your hand over that lot, the minus 1 from the top, get a minus 1 there. Okay, and I get a 2 from inside, times 2, and what do I get here? 2x plus 1 to the minus 2. Alright, so when I integrate this up then, what I'm looking to do, I'm looking to get rid of this. Yeah, so really I want to look at differentiating. Let's put a factor in here, or just put half, okay, with a minus sign there, and then I'm going to get rid of the minus 2 there, aren't I? So when I differentiate that, I get that. Well, I've got the constant outside to take care of it. Okay, so now why don't we go over to the rubber, okay, and get rid of this, because you see what's going to happen there. We'll get rid of that. Alright, good. So what's the next step then? So yeah, we're going to basically use this now, aren't we? So we now know when we integrate this up then, we'll take the minus a half outside, we're going to get minus pi all over 2, okay, so where the half's gone, minus a half, put that there, we're going to get 2x plus 1, okay, to the minus 1 from over here, okay, from b 2a, yeah? Move down a little inchy bit. What do we do next then? Simply we put the values of a and b in, okay? So we're on the home straight now. Minus pi all over 2, big brackets, 1 all over 2b plus 1 minus 1 all over 2a plus 1. Ooh, yay. I think it's when you hold it down that it just starts doing that. Okay. That's what we've got there then. All we've done there is put the b in the a. I've put it, put the minus 1 now, put it at the bottom. I'll put your b into the x there and your a into the x there. So it's quite a simple step we've done. Okay, so the final part then is just put this as a simple, remember what we read at the top? To get those extra marks, okay, express your answer as a single simplified fraction, okay? So yes, kind of money for old rope really, with a few extra marks there. Okay, so we come down here, and what are we going to finish this off? So we're going to take the minus and put it inside. Okay, I'm going to do that before I try and do anything else. Okay, put the things at the top there. 1 all over 2a plus 1 minus 1 all over 2b. b plus 1. Close your brackets. Now, obviously what we're going to do here, multiply top and bottom by 2b plus 1 to get this one the same at the bottom, and this one 2a plus 1 to get this one the same at the bottom. So let's have a go at doing that. Pi all over 2b plus 1, okay, 2a plus 1, okay, 2b plus 1, and let's not mess around here, we'll just put the minus brackets 2a plus 1 there, so going mad. I think we can all see where that's coming from, alright? So we need to simplify it down a little bit more than that. Okay, all over 2. Let's see what we can do here. So we can probably get rid of the 2 for 1. Why don't we do that straight away? Yep. Get rid of the 2 from there with the see the minus 1's going to, well, actually let's do it in a few more steps. All over 2. 2b minus 2a all over okay, so now we can cancel the 2's, can't we? Let's scroll it on a little bit more. So let's put the pi inside, so we're going to wind up cancelling those two 2's with that 2 there and put the pi inside, so that gives the final line then of pi b minus a all over 2a plus 1 brackets 2b plus 1. Okay, and that's your lot. That's pretty much the answer, I think. I'll just double check it with the mark scheme. See whether I got it right. Come on, up you come. Oh, let's open the question pack. Oh, mark scheme, here we go. There we go. There we go. There you go. And that's the answer. Let's double check it, shall we? Yeah. No real problem there.